So, are you all able to see my screen?
Yes.
Okay. So we will wait for 5 minutes if some are joining, and then we'll start. Okay. So I will start. Feel free to stop me in between if you have any doubt, and keep it very interactive so that I know means I can understand what is your expectation from this session. So I am Nitish Kumar, and I am currently a PhD student in remote sensing branch, Civil Engineering, IIT Bombay, and this course is taken by my guide, Professor J. Indu, and she is a professor in Department of Civil Engineering, IIT Bombay. So for today, what I will be doing is I'll be solving week zero questions, as those are not very numerical. So means many questions are directly like theoretical, and questions, some other questions, five six other questions, which will be based on week one. But those are not your assignment questions, because assignment submission is on Wednesday, so I will be not touching that. But some other questions similar to that of week one. So, and I will be giving some brief introduction about Google Earth Engine, which I am planning to take if you all are interested in future sessions. Where Google Earth Engine is like a cloud based platform where we can directly operate on remote sensing images. Like satellite images are already provided there, and it is very fast compared to what uh, we do in Python. So if all are interested, we will be going for that. Otherwise, you all can suggest like what you expect in this session. So anyone will like to say anything? Am I audible? Can anyone reply in message that I am audible or not? Okay. So uh, I am audible. So I will start now. So I'm starting with week zero questions. So this was first question, where we have to tell relationship between C, lambda, and mu. So uh, week zero questions are very basic. So I have nothing much to explain. With this question, this type of question, how you can do is one more thing is like with the unit itself you can do this questions. So here if you see C unit, which is speed of light, that is in meter per second. Lambda unit is in meter. So if you have forgotten formula, then also you will be able to do this question. And mu is 1 by time, so that is second inverse. So what you want is uh, C is given. So C is in meter per second, and for meter per second, lambda, mu and lambda, if you will multiply, that is, you will get same, like lambda is meter and this is per second, 1 by s. So by unit checking also you will be able to understand that this question answer is C. So one answer is C. How we write this is means unit, we denote by like time, mass, m, length, length is meter, and second. So here if we see C is L1 T minus 1. Okay. And similarly, lambda is in in any question you see lambda is uh, lambda is L1. So you want a T minus 1 to equate this. So mu also should be mu is also t minus 1. So if you multiply, then it will come t minus 1. So you can say c is equal to mu lambda even if you don't know formula. So like this we can arrive at the solution. So this was the first question. Now second question is IRNSS satellite, Indian Regional Navigation Satellite System, also known as. So if we know, if you know GP, one minute. So GPS is constellation of satellite which is uh, launched by NASA, and it is in US. So similarly, India is also launching satellite system, that is IRNSS. It has three geostationary satellite and four geosynchronous satellites. So these are the seven satellites which will be present in IRNSS, and that is also called as NAVIC. So you can see you have this answer as B. So this was just a theoretical question uh, to know how much update you are. Then third is the major layer of Earth's atmosphere arranged from lower to higher. So if you know, first layer from Earth, that is troposphere. Then there is stratosphere. Then mesosphere. Then thermosphere, and then exosphere. So this is the sequence. So if you see from lowest is troposphere. So A, or then stratosphere, then mesos, thermo. So answer is A. Then this is fourth question, like from where we monitor and control all the geostationary satellites of ISRO. What is that called? So that is this is direct question, so I have nothing to explain. This is master control facility. Then fifth question is, who is known as father of remote sensing in India? So this is also a direct question. If you will search, you will be able to get, that is Pisharat Rama Pisharat. Then sixth question is, Landsat 9 was successfully launched on. Okay, so in this you can know that there are Landsat is series of satellites. So Landsat 1 it has started, and currently we are on 9, and 10th also is in planning. So Landsat, from we started getting data from Landsat 4, that is 1984, and then there was 5, 7, 8, 9. This all are giving data. 5, 7 is currently 7, 8, and 9. We had recent data from this, and this bands also kept on increasing, and this is longest series of satellite which we are having data. So means we mainly we use this for time series analysis, as this only has longest time series. So Landsat Question is Landsat 9 was successfully launched on. So that was on September 2021. Then coming to seventh question, that was approximate wavelength limits in meter of microwave region of electromagnetic spectrum. So if you see, that is also a direct question, which answer means which was taught also in week one. If you see, that was B option. Here only it is written in meter. That was, so it starts from 1 millimeter. So if you convert that, we are getting 1/1000 meter. 1 millimeter to 2.1 meter. Now, this only in this question there was little calculation was there. So calculate standard deviation given the following data. So we have here 1, 2, 3, 4, 5, 6, 7, 8, 9. So our n is equal to 9, and if we find mean, then we have to add everything. So 10 plus 15 plus 5 plus 20 plus 25 plus 15 plus 10 plus 25 plus 10 by 9. So if we add 10, 25, 30, 50, 75, 90, 100, 125, 135. So 135 by 9 is equal to 15. So our mean has came to 15. Now if we divide 15 minus 10 equal to 5, mean minus xi. So mu minus xi we are finding currently. So 15 minus 10, then 15 minus 15, that is 0. 15 minus 5, that is 10. 15 minus 20 minus 5. 15 minus 25 minus 10. 15 minus 15, 0. Then 15 minus 10. 15 minus 20. So these are the mu minus xi. Then we have to find mu minus xi whole square. So that we will get by 5 square plus 0 square plus 10 square minus 5 square plus minus 10 whole square plus 0 square plus 5 square minus 10 square plus 5 square. So that is 25, 125, 150, 225, 250, 350, 375. So if you see, there are 300, 25, 25, 25, 25. So 100, and total is 9. So if we take that is 20 by 3. If this was sigma square, so sigma will be equal to root of 400 by 9. So up it is 20 square and down it is 3. So we will get 6.67. So our answer will be B. So in the till here, if anyone has doubt, I will come. Anyone has doubt till here, then they can raise their hand or type in chat box or unmute yourself. Please let me know. I will give 5 minutes. You can see all these 8 questions and tell me if you have any doubt. Then we will start from 626 again. Uh, you written, please proceed. I will wait for others, means, if someone wants to see. Okay, so I guess everyone has checked or solved. So I will start now. So now I will start from 10th question, 10th slide, that is ninth question. So this was also a theoretical question. Uh, Futuristic joint mission by ISRO and NASA Space Agency to provide information about biomass. So this is NISHAR. So one minute, one minute. So this is NISHAR. Uh, if you would have seen news recently, if you are following some means this field, then you would have seen from the payload has gone up from NASA and it will reach to India soon. So that was the news recently. Within 10-15 days, it was there. And in this, if you see, JSON is previous satellite, so this is not a futuristic mission. Same goes for Asmos. This is already JSON is already giving water levels or height for many, and SWAT also is launched. It was in December. It got launched, and this also mission. So only futuristic mission was Nishar only. So that was the answer. Then Asmos, as short form suggests, uh, it is S goes for soil and other is moisture. So this is a soil moisture which satellite which operates in L band and it provides information about soil moisture. So these were 10 questions from uh, week 0. From week 1 there will be more numerical, so we will have more questions to work on and more doubts. Now I will solve some other questions based on week 1, but those are not your assignments. So other question is convert 46 degree to radian. Uh, so you take 2 minutes and solve this question, then I will solve. Okay, so now I will solve. So if you see, uh, this is a circle. So this is 360 degree, and we say it as 2 pi. So total 360 degree is taking 2 pi. So 1 degree is equivalent to 2 pi by 360, and 46 degree will be equal to 2 pi by 360 into 46. So you solve this and then we can proceed. I will also use calculator and I will see what is the answer. So if you will solve, you will get 0.802 radian. So that is in option A. So answer will be A. So we will go to next question now. So question is, if a wave completes one complete cycle in 30 seconds, what is its angular frequency? So again you take 2 minutes, then I will solve. First you try to solve. Okay, so now I will solve this. So question is, if a wave completes, so 30 seconds it is taking from reaching. So other way we can write is, this is taking, it is covering whole cycle, that means 2 pi in 30 seconds. So its angular speed will be, the angular speed is angular displacement by time. So angular displacement is 2 pi and time is 30. So if we say this, this is pi by 15 or 0.209 radian per second, which is option B. 1 minute. So take some time and understand the solution, and then I will start next question. Take 2 minutes to understand. If anyone is having any doubt, please tell. Work simultaneously so that you don't have to give any extra time other than this. And this videos will be uploaded on YouTube. Okay, so we will go for next question. So question is, an electromagnetic wave has wavelength of 650 nanometer, then calculates its energy. So this also would have been taught in first week. So you can try to solve it. Then after 2 minutes, I will solve it. Okay, so now I will solve it. So, as you would have learned in week 1 lectures, energy is E is equal to hc by lambda, where h is Planck constant and c is speed of light and lambda is wavelength. So, if we put our in formula constants, then h is 6.626 into 10 to the power minus 34, and then 3 into 10 to the power 8, that is in meter per second. So lambda also, as we have taken this both in SI units. One minute, someone is joining. So as we have taken this Planck's constant in SI unit and C is also in SI unit, so we have to take this wavelength in meter. So 650 into 10 to the power minus 9 meter. So calculate this. By calculation, you will be getting 0.03 into 10 to the power minus 17 joules. So our option is this. So now you take 2 minutes to understand, and if you have any doubt, tell me. Then after 2 minutes, we'll start next question. Okay, so now we will go for next question. So question is calculate wavelength of the wave with frequency of 500 megahertz. Assume C equal to 3 into 10 to the power 8 meter per second. So you this also you would have read in week 1. So you try to solve it. Take 2 minutes for it. After you solve, I will start solving after 2 minutes. Okay, so now I will solve the question. So uh, today only we saw the relationship, that is C is equal to mu into lambda, and how you can figure out this also we saw by comparing unit. You will be able to know. So C is in meter per second, mu is 1 by second, and this is meter. So like this you can remind yourself. And here our mu is given and C we have. So lambda we want to know. So as C is equal to mu into lambda, so lambda equal to C by mu. So lambda C is given here. So 3 into 10 to power 8 meter per second, and mu is 500 megahertz. So that we will convert mega. So this is 10 to power 6. 1 hertz we can write as 1 by second. So as SI unit is 1 by second, so we have to convert this megahertz into hertz. So that is 500 into 10 to the power 6 hertz. So if we solve this, this is 100. So we will get zero point 0.6 meter, that is equal to 60 centimeter. So our option is D. So you can take 2 minutes to understand it, and then we will start with next question. 1 minute. Someone wants to join session. Someone has told earlier something 0.209 option B. B. Okay. Okay, this question. Okay, that was right answer. So I will start next question. Now next two questions are related to Python. Next two questions are related to Python. and that is what is the conduct. 1 minute, someone is joining. Okay.
Hello, sir.
Hello. Yes.
Can you show me the previous slide?
Previous slide. Which question? This.
Yes.
Okay.
Uh, this previous, previous.
This.
Correct.
This one.
Yes. This one, yes.
Okay.
I have 2 minutes. ठीक है sir.
Okay. So after 1 minute, I will start. He wants to say this. Okay. So shall I move forward?
Yes sir.
Okay. So now this question. So what is the conda command to install a library? So if any tutorial was taught, then you will know that is conda install, and suppose we have to install GDAL, then we give conda install GDAL or any other package name. So answer is C. So this was direct theoretical question. So I will move to next question, and this I will show you also how you can do. For now, will you take 2 minutes and you just figure out answer without using Anaconda or any Python notebook. Just do it manually, and then we will see. So this is the last question for today. Then I will tell you about Google Earth Engine later. Okay, so now I will tell you. So how this works is, uh, in for loop, first we are telling for I in range 0 to 10, if I percentage 3 is equal to 0, then print I. So what will happen? First 0 will come, and 0 percentage 3 equal to 0. So that means remainder should be 0 when it is divisible. So if we see 0 divided by 3, so yeah, so then it will print 0, because print I, so I value is 0, so it will print 0. Now when 1 is, we are trying to divide by 3, then it will not give remainder as 0. So remainder will be 1. So this statement is false. So if this statement is false, we have not given any command. Like if it is not divisible, we are not telling to print. So 1 will not be printed. Then it will come to 2. Then if 2 is divisible by 3, no. So again this will not get printed. Then it will come to 3, and 3 it will be divisible by 0, 3, so remainder will be 0. Then 3 will get printed. So 0 will get printed first, then 3, then next which is divisible is 6, then next which is 9. So this all will get printed, and this I will show you in Python also. So for that, if you know about collab, I hope these slides will be shared. Yeah, I mean, slides will not be given, but YouTube video you will be given. So in that you can see. And I'm going to have you heard of collab? Every one of you, can anyone can tell me? Yes. Okay. So we are going to collab, and because these are here any library we don't have to install. So just take 2 minutes and I will be going for collab after that. So so what you can do is, if you have any doubt, uh, you can tell me by that time. Uh, then I will start. You can take 2 minutes. If anyone has any doubt, tell me by then. Since previous question or any other thing. Okay. So someone has asked in. Can you use any online Python compiler for this code? Yeah, so collab is that only. Are you able to see my collab screen or only PPT screen only is visible? Can any one of you confirm? I think PPT screen.
PPT is visible.
Okay, okay. So I will stop that and I will share again. Okay, so now I guess one screen will be visible. Uh, collab interface.
Yeah, now it's visible.
Okay, so I have written same thing for I in range 0, same code which I gave you as question. So what happens here? See, you can see 0, 3, 6 and 9 is getting printed. And in Python, this last is not taken. Means if we are telling 0 to 10, that means this code will go for 0 to 9. Last digit is not included. So if I can show you that if you make here 0 and here 9, that means 9 this will not take and this will get printed 0 to 6 only. 0, 3 and 6 only will get printed. So you can see this because it has not considered 9. Okay. So uh, this was, and one more Python question was there, that conda install. So that anyhow when you are installing library you would have used that code. Now, so anyone has any other doubt till here? Otherwise, I will give you some means little bit of uh, Google Earth engine. Okay, so I will open that Google Earth engine. Are you able to see means one PDF where I have written about? Someone has raised hand. Can you tell me what is your doubt? No doubt. Okay. Okay. So I guess you are able to see this Google Earth engine one intro I have made. So any one of you have used Google Earth engine before? Can you reply in chat box or you can say something? If you have used, just tell me. Or this will be first time. I just want to know. So I guess no one has used. No one is telling anything. Okay, so generally in Python, we will be working on one image. What Google Earth Engine, we can use multiple images at a time, and it is in more efficient way. But what the problem is at Google Earth Engine, that it doesn't have all data. Means uh, all satellite data are not available there. Like if you, I think Elos Pulsar, which we would have used, that is not available here. But Sentinel-2 data is available here. So all new data which are coming are mostly available here, but many previous data are not available here. So that is one back point. So Python we prefer because we can download our data and we can use on it. But uh, Google Earth Engine has different advantage. Like Google Earth Engine, you don't have to download data, you can process your data there itself. So that downloading time and other things are saved there. So it is a cloud based geospatial platform, uh, and it has, like, if you see Landsat, then it has Landsat data is available from Landsat 5, 7. Every Landsat data is available here, and Sentinel data also, and Modi's data. These all are available there, which are very commonly used, that are available there. And you can see it deals with petabytes of imagery using Google Cloud. It is very fast. Some Python, how much time you will take to process? Here, those much time means here in that much time, very less time you will be taking to process here, and it is free. So what we have to do is, if all are interested, you just have to. I will next class also, every class half an hour. Uh, if everyone is okay with it, we will give to this, and I will teach you something based on this, and other parts we will do numericals. Based on your feedback only, I will decide that. Otherwise, we can go only for numericals if you all are not interested in this. And one other thing can be, uh, like, you will not use it, and just I will teach you something. Maybe that also can be done. Whichever is okay for you, you decide. And this just go to, means if you will type Google Earth Engine, just sign up. If you are, you can process now itself, so that if you have any doubt, you can show to me, and we can and solve it here itself in signing up if you have any doubt. So it will ask you some questions, some basic questions. There you can give, like, you are using it for academic purpose, and what project you will be using. So in that, any project you can give, like, you are using on for land cover, land use, some project you write like that, and fill the basic information of yourself, and within one day your account will be started. So I will show you that also, how it looks. So what are the elements? So I will open that, and I can tell you on.
Can you zoom it? Yeah, still more you can you zoom it?
Okay, okay,
Yeah, it's fine now.
okay. So when you will open interface, it will look something like this. Here new script is written. This uh, there we write our code to perform whatever task we need. Here in essay one, first is scripts. So we will make new files here, and our scripts will be saved online. We no need to do anything. Just we have to log in account every time, and our previous scripts will be also shown there if we are saving it. that is scripts. In that also there are one is owner. So if we want, we can share our script to other person also, and maybe at same time two persons also can work on same script also. So here one owner is there that will be visible only to us, means we have not shared it with anybody. And if someone has shared any script to you, that will come in read, means if he has not given permission to edit to you, then it will come in reader part. And if he has given permission to edit that code also to you, it will come in writer part. And here in Google Earth Engine, examples are also there. In that, many codes are written, pre-written codes, which are given as examples. So just one run button will be there. I will be telling about you about that to you. So these codes are like pre-saved, so you, so that you can understand what means what can be done and how it is done. So here those things will be written, and there will be comments in that. So comments will be written in green, so that you know which step is used for what. Here I will be teaching you, so you no need to worry for that part. But then also after my teaching also, you can go in example section and work on these things. And then this, if you see here, docs is written. So docs is like they have made one many documents. In that they have told like which code is used for what, means one reference they are trying to give. Because there are many things and everything can't be remembered in code. So they are giving one doc section also, which is near to a script. Then there is third section called asset manager. Here you can down, means you can upload your save files, or any CSV file you want to upload. Those things you can upload, like you want to do analysis of particular area, so you will need a save file of that. So that Google Earth Engine will not provide you, so we have to upload that save file. I will be opening my account at last, and I will show you those things. uh, this terminology if you know, then it will be better. And here, uh, where it is showing search, fourth part, there we can search like what data is there here to analyze. So there are many set of data here available. Then fifth is get link, means if I want to share my code to someone, then we can click on get link and we can send that as code in mail or something. Then that person will receive the code, and if he has Google Earth Engine, he can edit from there also. And sixth is, this part is for saving the script. And seventh is run after writing, or if you want, as you don't know now, so you can open example section, and if you will run, then it will process the image which code is already written, and it will show you. That also I will show you now. And other is inspector, which is 10th part. So after running the code, if you will go to any section and click it, after going into inspector, then it will show the details of that part where you have clicked. So inspector is for that reason. Ninth is console output. Like in Python, you would have seen we write, if we want to see anything, we write print. So here also, if you want to see anything, you have to write print. Those output you will be shown in this console window. And eighth is task. So after analysis, if you want to save any image, any small portion of image or full image also, then that you can download from task section after you have written code for downloading it. Or you can save the CSV, and this all things which you will do, it will go to your drive. In your drive only, Google Drive, you can save these things. So that is and here There are geometry tools with which you can make save files here and give that as input for processing image. So this all we will learn actually slowly. Okay, so I will just open my account and I will show you how it looks really. Okay, I am willing to learn. This class is on every Tuesday. Yeah, this is every Tuesday 6 to 8. This will be there. Okay, so now I will open my Google Earth Engine account. Okay, I will show you. Okay, so my screen will be visible, I guess. Here we have to type code.earthengine.google.com. Okay, so when you will be type, if you have not signed up, you will be given different things and you will be told to log in. As I already have account, I am given this interface. So which things I told you, you will be able to see it. Now you see here in assets, I have some things already. So this is like Rajasthan save file which I have uploaded. So if I click on that, uh, this is the Rajasthan save file which I uploaded. You can see it. So that I have uploaded in asset section. And how we are uploading is you go in asset new, means we will be learning in future when we'll need it, but today I want to give you an introduction. So asset new, then save file we can upload here by selecting any save file which we have, we can upload here. And like here if you see there are many documents, so suppose image collection we are working. So all code related to image collection, feature collection, whichever we are typing will come here. And like if we know little about it, how we are doing, we can see it from here. And first we need is some examples. I will be teaching you means from very basic, so you no need to worry, but I am just telling you so that you know what is happening and you can just try if you want. So one example I will show. So if you go in example section image and just click on normalize difference. So here someone means they have uploaded code from Modi's. This is okay. First I will tell you how you can search for data. So here when you click this search section, you will be clicking. Then browse data catalog will be coming, and then click on view all dataset. So you can see here how many data set is there. If you will go on scrolling, there this many satellite data are uploaded already. So this is in huge in number. Now suppose we are working on cent. I think Elos Pulsar is not there. I will just check. It is not there. Sentinel, if you see, it is there. So we search for Sentinel. So this much sentinel data are there, means this much different. Now if we want any product, suppose sentinel 5p is giving near real time sulfur dioxide. So if you want sulfur dioxide, just click on this. Some example codes will be written in every data. So here we can see this data, it is written like which collection. So this is taking sentinel 5 data. So we will be working on microwave, so we will be taking that sentinel data that I will show. For now I am just showing you sentinel 5 data. And if you will click in open code editor, so and if you will click after coming here to run, then you see now down result has come. So this is, here one layer is being added, which is sulfur dioxide. So if you zoom to any portion, we will zoom to India. So here if you see, minimum is represented with black, that is 0, and 0.0005 is given to red. So this red areas is 0.05. If we, here I told you inspector, then if you will click on inspector, this pixel is how much that it will show to you. So this pixel is 0.0001. Here you can read that. So this is like uh, Sentinel 5 data, which is 1 June 2019 and 11 June 2019. So this is from this date. Now, if you think Sentinel 5 data, you will be downloading it and then you will be seeing, with you will apply some correction and then you will be going for your area and then you will be able to produce this map. So that much time you are able to save for one image itself. And here if I give 10 images also, and for one area it will be able to process in 5, maximum 5 minutes you can do this. So this is how. And example also I will show now, like we were seeing normalized difference. So this data is Modi's data, and this is some product which they are taking, which will be surface reflectance I guess, and this is this date data. And then they are making it NDVI image. For that, green means NIR minus red and NIR red, they are dividing, and they are making NDVI image, and that layer they are adding here. So any, like from name or normalized difference I have given. So if I run it, you will be saying this is some other country data, and here NDVI layer has came. And similarly inspector, if you will click and you go to any area, then what is NDVI value there for that particular date which image has been taken, you will be able to know. So that is 0.29. Similarly, for you can cut for your area like Rajasthan, and you can take min and DVI. So those things I will be teaching you in future lectures. So till then, if you want to, if anything is of your work, like from, you can go in image or image collection, and you can see like anything you want to work on, then you can just see here how it is done. Anyway, I will be teaching, but then also if you want. And here data sets are also there, like which data sets to visualize, we will be using Sentinel. But here every data has one example, like how to take it and how to add it on your map. Those examples are already here. So this for today, this much only. And you can tell, like, if you are not interested, you can send me mail, or you can say before next class, so that I will not prepare for it. Otherwise, last 15 minutes or last half an hour we will be giving to this, and I will be showing you, and you can work simultaneously with me, so that if you have any doubt, you can tell me that time itself, because this requires means someone guidance to learn. So from next time 7:30 to 8 we will be giving for this, as this was first class. So uh, I was not knowing what to do. So in next class, please make an account and come for Google Earth Engine. If it is any problem is coming, you email me. Means there one means in course one doubt you can ask. So you ask through that portal. I will be clearing there. Like if any doubt is there in sign up, or you can search in means YouTube also how to make account. So you can make Google Earth Engine account and come. And in next session what we will be doing is, first, as this time I have solved only week 0 questions, and some 5 questions I took extra. So next time, as week 1 and week 2 deadline will be already over for you, which is tomorrow, I guess. So I will be solving first week 1 and week 2 questions, and if time is there, then we will solve some extra questions, and then we will go for this Google Earth Engine. Or any doubt in Python also you can tell me, so I can solve those for you. Or you can ask before also in portal, so that whenever time I will get, I will keep it solved for you. Otherwise, if you ask, then numericals are okay, I will solve there itself. But in Python, if there are some issue, and it may not be resolved that time itself, uh, please share the PDF. Okay, one minute, here I can upload PDF. Uh, Whoever wants PDF, can you give your mail ID in chat box? Then I will be able to share PDF for that Google Earth Engine, which I showed. I, you just write your mail ID in chat box, then I will be able to share with you. Okay. So after this class, I will be sending you mail. So next class, week 1, as I told, week 1 and week 2. First we will solve, and then we will go for Google Earth Engine in last half an hour. Now, if you want, you can leave. Means that is all for today. Or if you have any doubt, you can tell me.
Sir,
Yes,
yeah, this is Kirupagaran.
yes,
I really thank for your efforts and your preparation.
yes.
Can you kindly increase that Google Earth session some more time, sir?
Yeah, yeah.
For
Whenever I will finish that previous year, previous
previous assignments.
online means questions, I
Hmm.
will solve, and after that I will go for Google Earth Engine.
Yeah, please try to increase that session's time, sir,
Okay.
because I hope that much more helpful to us.
Yeah, yeah.
Actually, that assignment session is helpful, but this is quite interesting. That's why I'm saying.
Yeah, yeah. I will
Thank
do
you.
that. Yeah.
Thank you. Thank you.
Thank you. Anyone one other wants to say anything, then tell. Otherwise, this session is over. I'll be sending you mail by 8 o'clock. Okay, so you would have got the mail. Are you there? Uh, sh- okay.